Before we understand what Deno is, we need to know how the internet works. When a user opens up her browser and makes a request to a site, she's known as a client. For example, here we have our laptop and makes a request, which is colored in red, to a server. The client makes a request of a certain website to a server, which upon receiving the request, responds with the content of the requested site to the client, who then displays it in her browser. For example, I make a request to Amazon.com and Amazon servers respond back with the HTML for Amazon.com. There have been server-side programming languages like PHP, Ruby, Python, ASP, Java, and others which help us respond to browser requests appropriately on the server. Traditionally, JavaScript is used to run only on the browser to provide website interactivity, for example, drop-down menus. But in 2009, Node.js took V8, Google Chrome's powerful JavaScript engine, out of the browser and enabled it to run on servers. Thus, in addition to the existing server-side languages, developers could now choose JavaScript to develop server-side applications. Deno, like Node, is a JavaScript runtime that allows you to run JavaScript code outside of the browser. If you are watching this course, there is a high chance that you have worked with Node before, and even if you have not, don't worry, as we will start from scratch. Like Node, Deno is based on Chrome's V8 JavaScript engine, but enriched with server features that let us do things we can't do in the browser. For example, interact with files on our local file system. If you have not already realized, Node and Deno are anagrams of one another, and this is deliberate because Deno was actually created by the creator of Node, and Deno is a deliberate reference to Node. The creator of Node created Deno to fix some of Node's so-called flaws, but it doesn't mean that we got horrible problems in Node and we should all just use Deno. We will revisit this later. First, Node by default only supports JavaScript, but Deno on top of JavaScript also supports TypeScript. The compiler for TypeScript is baked into Deno, so you can start writing TypeScript and Deno will compile it. Second, Deno is newer and embraces more modern JavaScript features like TypeScript support, URL imports, promises, etc. Because Node is based on older JavaScript code, it doesn't really support promises and typically uses callback functions for asynchronous Node. This will be clearer as you progress along this course. But Deno also imposes security permissions on running scripts. By default, a Node script can execute anything, for example, read or write files without permission. This can be a problem if someone has a malicious intent. Deno is secure by default, meaning that scripts executed by Deno require explicit permission to do certain things, for example, reading and writing of files. We will explore this in a later section, working with permissions. Oh, should we switch away from Node? These flaws of Node cannot be so horrible, else Node won't be as big and popular as it is. If you do not need the mentioned features, understand that Node is established, has a highly active ecosystem, is used by thousands of companies, has a vast base of maintainers, has a lot of third-party libraries, and is production proven. It is a fast and secure technology you can use for big apps. But Deno is here to provide a better version of Node with extra features and solve some of its problems. At the moment, Deno is still pretty new, has a small ecosystem, has a smaller base of maintainers, and is not used in production by major companies. But that doesn't mean that using Deno is a bad choice. In the coming future, we could have a nice coexistence of Deno and Node, so it brings tremendous opportunities to be an early adopter of Deno. Deno share many more similarities with Node than differences. And because of the similarities, if you know Deno, it will be quite easy to pick up Node. Conversely, if you know Node, it won't be too difficult to pick up Deno. The key is, no matter which you are learning, you will have a good time learning the other. you can quickly transfer Deno knowledge to Node and vice versa. Because you are still learning Deno, the similarities and differences that we mention here might seem abstract. Thus, in the last portion of this course, after having gone through implementing a Deno app and being more familiar on how Deno works, we will revisit a comparison between Deno and Node, which will be more meaningful. Before we get started with writing our first Deno program, let's first install Deno. If you visit deno.land, find the Deno homepage and installation instructions for it. Click on Install. Brought to the installation instructions for different environments. You can use any of the approaches depending on your operating system, but because I am using a Mac and I am using Homebrew, I will copy and paste the link brew install Deno into my terminal. So brew install Deno and enter. And when you do so, you will download and install Deno on your machine. When the installation is done, as the site suggests, try running a simple program in the terminal. So you can copy this and in your terminal, paste it. And what you should have is, you should get welcome to Deno and with a dinosaur icon printed. A note here, the application we ran just outputs a text on our command line. However, it also shows us how a Deno application can be executed from a remote source by downloading and compiling it on the fly. Also, just type Deno in the terminal, which will start an interactive environment where you can run Deno code. Now, we won't write code like that in our actual programs, of course. We will have our codes in files, but this environment is nice for playing around. For example, you can enter code like 1 plus 1 plus 1. We will create our first server to handle incoming requests and send back responses. First, let's create a directory to store all our Deno files. I will make drive, and let me just call this Deno underscore Udemy. I will open my code editor. In this course, I will be using Visual Studio Code, and I strongly recommend that you also use Visual Studio Code. Reasons will be more apparent later, but for now, just open your code editor and open the folder that we have just created. I created Deno Udemy, open. And in the folder, I'll create a new file called first app.ts. .ts standing for TypeScript. We have the code to create our first server. First F import serve. And from this particular path. And see, what we have here is actually a URL. Deno supports importing modules from a URL. In this URL, we import server.ts from the HTTP server module. And you can actually refer to the source file of this server.ts at this particular URL to look at its source code. So if we just copy this, paste it into our browser, there we have server.ts and we have the source code over here which we can refer to. Now server.ts, it's built using the core APIs of Deno, so which you can even do on your own. Now of course, not now, else you won't be reading my book. But other maintainers have done it so that we don't have to re-implement it ourselves. Now, note that we have specifically imported the 0.63.0 version, which is the latest version at the time of this recording. Now, of course, we can just import the latest version, for which we would do something like this instead. We are not doing this. We will import 6.3.0 to ensure that the code in this course doesn't break. But of course, you can use the latest version on your own, and if there are errors, you can try to Google and solve them on your own. Now, server.ts over here, it exports a serve function which creates a HTTP web server. You can actually refer to Deno documentation where it talks about the serve function. So serve here creates a HTTP server, and you have some sample code. Now next, we have const s equals to serve, and then port 8000. So over here, we call the serve method, and we specify in its parameter an object with the property port to the value of 8000 to configure the port we want our HTTP server to listen to. The serve method will then return a server object which we assign to the variable s, and then we can use s as you would any object. Next, we have a for loop, await and cause request of s, and in this for loop what we do is we have to request, respond, and body hello world new line. So what we have here is we have a for loop to loop through all the requests that our server receives. Now notice that we have await in the for loop, and this is to ensure that we await for each request to come in to provide a response, and after completing this, only then move on to the next request. Note that we also can use the await keyword here without having to wrap it into an async function, because Deno implements top-level await. This is an example of Deno embracing modern JavaScript features. We respond to incoming requests with request.respond, and with the body of the response being hello world new line. With this code, we can run it now to have an ongoing server that starts taking requests, and the server will listen on port 8000 for requests. Let's save this and go back to the terminal. Let's cd to the directory that we have just created, and we have our file first step over there, and we run it with the command deno run -- allow.net first app.ts. We get some error. Now let's take a look at what is this. I forgot to put from in the import. Okay, so import serve from. Okay, let's save this again, and now the error is gone. Let's run it. And we actually have our server running now. So for any request made to port 8000, we should respond with hello world. Now let's go to our browser and let's enter localhost 8000. Browser, we should see the text hello world displayed. This is because back in our first app.ts, we have responded with the body being the text hello world. Now, localhost, of course, in this case refers to our own machine acting as a local server. But suppose the server is hosted on another computer or site, or you would replace localhost with that machine's IP or address. Now have a successful request and response cycle, and I hope that this serves as an introduction to understand how a request and response works between the client and a server. Notice that in our command to run our server, we had to specify --allow-net to run it. Now, why do we have to specify this? let's say if I stop the server and if I just run Deno then first app.ts, what I will get is error like saying uncaught, permission denied, network access to so and so. So run again with the --allow--net flag. By default, Deno scripts cannot read, write files, use environment variables, or interact with the network without permissions. In contrast, Node scripts can execute the above without asking for permissions. You have to explicitly assign permission to run Deno scripts. For example, to allow interaction with the network, we have had to specify --allow--net. Find out about more other permissions at the Deno manual. Now, some common ones are, for example, --allow--read to allow file system read access. And to allow a script to write files, we have --allow--write. So you can read this document on your own, and we will come across other permissions in the course of this course. Now let's run our server again with the --allow--net. And if we do so, we have our server running again. Now, say for example in our URL, if we put about behind, it will still respond with hello world, regardless of the URL entered after 8,000. So I can put 123 here, and it will still do the same. To have different responses based on different URLs, for example, if we have /about, we want to respond with a different message. Let's do this now. So what we do here, if our request.url is equal to /about, we'll respond with the about page. Else if request.url is contact, or I can do without the curly braces here, request.respond, and body here being the contact page. And also, let me just copy this. Else if the request.url is just a /, I would say responds with the home page. And else respond with body being page not found and with a status 404. Let me just add the semicolons here. And I should put another parenthesis here. So using an if-else statement in the body of the for loop, we check for the request URL, and depending on its path, we respond with different messages. If the URL is about, we serve the about page text. If it's contact, we serve the contact page text. And if it's just a /, we serve the home page. And if the path does not exist in the if-else, we default to the last else clause and respond with page not found and specify the status property with 404. This property sets the status code of the request. So normally a status code of 200 indicates that the server responded with a successful response. If it's an error, it should respond with 404. Now let's run this script. And wherever we make a code change over here, we should actually stop the server first. And then we have to rerun it because there's a code change. On, we will show how to avoid this manual process of quitting and restarting servers. So if I go to about, I get an about page now. if I go to contact, I get a contact. If I just have slash homepage, and if let's say I just have a 123 invalid route, okay, what will I have? We can see the status code of our request by going to of the Chrome bar, View, Developer, Developer Tools, and then we have the Developer Tools panel here. See your request information. In the Developer Tools, click on Network, and under the request for this route again, do a request for an invalid route. I get page not found, as well as I will get, you see the status here, 404. But if the path is a valid one, for example, homepage, the status is 200, which indicates an OK request. With this, we can handle different requests from a client and send the appropriate response from the server. We have been responding to requests with static text. So the about page, the contact page, the home page. But in a real-world setting, we want to respond with HTML. And let's see how we can do that here. Now back in our file, first-app.ts, we will first add headers equal new headers, and then we do headers.set, and the content type, it's going to be text./html. We are going to add headers to our response to contain metadata. So with this headers, it makes it clear to the browser that we are sending back HTML code. So the browser will thus display the HTML correctly and not interpret our response as plain text, but as HTML. So we carry on to, in the body, what we have to do is put the h1 HTML markup and close it, h1, and then next we have to specify in the headers property headers that we have just defined. To make this look better, we can do this so that it looks clearer, and we do the same over here, h1 slash h1 in headers. Okay. This up, do the same for homepage and page not found. In the end, this is what we should have. Instead of containing just static text, what we have now is simple HTML. Over here for about, contact, for home, page not found, and with a status 404. So let's go back to our terminal. Let's stop the server, run it again. And then if we go back to our browser, and reload, and yes, what we have now is HTML. Now let's just try for contact page, for about page, and just some random invalid route, and we have page not found. And that is how we respond to requests with HTML. You notice that we have been using a huge if-else in our single script for our entire application. The script listens to a web browser's request, either from a computer, mobile phone, or any other client consuming our server. So we call this script a request handler. When a request comes in, this script looks at the request and decides how to respond. For small sites, this might seem appropriate, but things quickly get huge and unmanageable. As you can imagine, for example, a site like Amazon.com, which includes rendering dynamic reusable HTML templates, rendering and uploading of images, etc. We explore in the next chapter how we use a third-party library called Oak to help us to solve this problem and make it easier for us to write web applications with Deno. If you have not already done so, you should install the Deno extension in Visual Studio Code. And you can install this Deno extension by the top bar, go to View, and then go to Extensions. So over here, Extensions, and then search for Deno. And then you should see the Deno extension over here. So make sure you install this. And when you do so, you are coding, you will get suggestions on what libraries that you can use. And with this extension, you get a much nicer development experience in Deno. In this chapter, we learned what Deno is and how its features make it an improvement over Node. We went through the steps to install Node. We created our first server to understand how a request and response cycle between a client and a server works. We handled requests and responded appropriately with both text and HTML. In the next chapter, we learn about Oak, a middleware framework that makes it easier to develop Deno web applications.